quantum mechanical laws, unveiling the secrets of the universe. Ever wondered what governs the behavior of the tiniest particles in the universe? Prepare to have your mind blown as we delve into the fascinating world of quantum mechanics, a realm where the rules are unlike anything you've ever imagined. Quantum mechanics is the set of physical laws that governs the behavior of matter and energy at the atomic and subatomic levels. It's a world far removed from our everyday experiences. This realm challenges our classical intuitions about how the universe works. Things aren't always as they seem when we zoom into the smallest scales. Quantum mechanics provides the fundamental framework for understanding the building blocks of reality. It explains how atoms interact, how molecules form, and how light behaves. One of the most fundamental concepts in quantum mechanics is quantization. This means that energy and other properties don't exist in a continuous range of values. Instead, they exist in discrete, specific amounts like steps on a staircase. Imagine only being able to stand on specific rungs, never in between. This is in stark contrast to classical physics, where properties like energy can vary continuously. Think of a ramp where you can stand at any height. A classic example of quantization is the energy levels of electrons in atoms. Electrons can only occupy specific energy levels, jumping between them by absorbing or emitting energy in discrete packets called photons. Another example is the spin of particles, which is also quantized. Particles can only have specific discrete values of spin, like spin up or spin down. Quantum objects such as electrons and photons exhibit a bizarre behavior known as wave-particle duality. They can act as both particles and waves. Think of a particle as a tiny localized object with mass and momentum. It's like a tiny billiard ball. A wave, on the other hand, is a disturbance that spreads through space, exhibiting properties like interference and diffraction. Think of ripples in a pond. The Schrödinger equation is a fundamental equation in quantum mechanics that describes how the quantum state of a physical system evolves over time. It's the quantum equivalent of Newton's laws of motion. The solution to the Schrödinger equation is the wave function. This function provides a probabilistic description of a particle's state, including its position and momentum. The Heisenberg uncertainty principle is a cornerstone of quantum mechanics. It states that there is a fundamental limit to how precisely we can know certain pairs of physical properties simultaneously. A common example is the relationship between a particle's position and its momentum. The more accurately we know its position, the less accurately we can know its momentum, and vice versa. Imagine trying to pinpoint the location of a fast-moving electron. The more precisely you try to measure its position, the more you disturb its momentum, making it uncertain. This isn't just a limitation of our measurement techniques. It's an inherent property of the quantum world. Quantum entanglement is perhaps one of the most mind-boggling phenomena in quantum mechanics. It describes a situation where two or more particles become linked together in such a way that they share the same fate, no matter how apart they are. If you measure a property of one entangled particle, you instantly know the corresponding property of the other particle, even if they are light years away. It's like flipping a coin and instantly knowing the result of another coin flipped simultaneously on the other side of the galaxy. Einstein famously called this spooky action at a distance because it seemed to violate the principle that nothing can travel faster than light. Quantum entanglement has profound implications for quantum computing and quantum communication. It could enable the creation of incredibly powerful computers and secure communication channels. Quantum mechanics has revolutionized our understanding of the universe. It reveals a world governed by probabilities, where particles can exist in multiple states simultaneously. It shows us that observation itself can alter the system being observed. The act of measuring a quantum property forces the system to choose a specific state. Despite its strangeness, quantum mechanics has been incredibly successful in explaining and predicting the behavior of the fundamental building blocks of nature. It's the foundation of modern physics and chemistry. Quantum mechanics has paved the way for countless technological advancements. It's the underlying principle behind many of the devices we use every day. Lasers, for example, rely on the principles of quantum mechanics to generate coherent beams of light. They are used in everything from barcode scanners to laser surgery. Transistors, the building blocks of modern computers, also rely on quantum mechanics to control the flow of electrons. Without quantum mechanics, we wouldn't have smartphones, laptops, or the internet. Medical imaging techniques like MRI, magnetic resonance imaging, use quantum mechanics to create detailed images of the inside of the human body. This allows doctors to diagnose and treat diseases more effectively. So, are you ready to dive deeper into the quantum world? Explore the fascinating concepts of superposition, quantum tunneling, and quantum field theory. The universe is full of surprises waiting to be discovered. Now that you've had a glimpse into the mind-bending world of quantum mechanics, it's time to take the next step. Like this video, subscribe to our channel for more mind-expanding science content, and share this video with your friends to spread the quantum knowledge. Also, check out the links in the description for further reading and resources to continue your quantum journey. Don't just be a spectator, become an explorer of the universe.